Lesson 11-2, Composite Figures and Geometric Probability. A composite figure is a figure that's made up of other figures. So to do your surface area and volume and perimeter, you just have to think about the way they're put together. So let's look at this first one. What we're seeing is we have a triangle on top of a rectangle with half of a circle stuck on the end. We're asked to find the perimeter and area, so let's start by figuring out everything we need for perimeter. Perimeter is the distance around the outside, which means we're going to need this length and we're going to need this length as well as the ones that we're seeing. So based on this dotted line here being 6, we can see that this one's going to be 6. The 12 is going to carry over up here. So I have a Pythagorean triple for my triangle right here, 5, 12, 13. And this part is going to be half of the circumference of the circle with a radius of 3. So this is going to be 1/2, or we can use pi times diameter here, so half of 6 pi, which would be 3 pi. So now all we need to do to find our perimeter is add all the way around the outside, here, 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 and around that circle. So 13 plus 5, that looks like a B, 13 plus 5 plus 6 plus 12 plus 3 pi. So when we add all of this together, we're going to get 36 plus 3 pi, and this is measured in centimeters. So now let's look at area. It's the same idea. It's frequently helpful to make a plan when we start. So for the area, I need to do the area of the triangle plus the area of the rectangle plus half the area of the circle. So for our triangle, this is 1/2 base times height. The base of the triangle would be 12 with a height of 5. So this gives me an area of 30 for the triangle. The rectangle is length times width. So this is going to be 12 times 6, or 72 for the rectangle. The circle is 1/2 pi r squared. So this, my radius again, is going to be 3. So 9 divided by 2 is 4.5 pi. And so what we need to do to find our area is add all of this together. So my area would be 102 plus 4.5 pi. And since it's area, that's going to be square units instead of linear units. So now let's look at what happens when we take pieces out. Okay, so our next figure, I have a trapezoid, and what I've done is taken out a triangle. So when I look at this, in terms of finding the area for this figure, I want to do trapezoid minus triangle. The area of the trapezoid is 1/2 base 1 plus base 2 times the height. My two bases are 3 and 8. I'm sorry, 10 and 8. And the height is 7. So the half of 18 is 9 times 7 would be 63. My triangle, the formula for the area of a triangle is 1/2 base times height. For my triangle, my base is 3 and my height is 7. Half of 21 is 10.5. So when I add these or subtract these two, because I'm looking for the area just of this shaded region. So when I subtract those two, I'm going to get 52.5 square feet. I want you to stop the video now and try the next one on your own. Think about what it is that makes that figure up and go find the area. If you had trouble, here's a little bit of a hint. What you're looking at is a rectangle minus 3 of the same circle. I've got your formulas here and your labels on there. So if you had trouble setting it up, stop the video again and try to put your numbers in and figure this one out. You should get 110 minus 12 pi squared units. You cannot subtract the 12 from the 110 because 110 does not have pi on it. So now let's go look at the next page. These are the same idea, but this time we're looking about three-dimensional figures. First one may be a little difficult to envision. It's even going to be more difficult to draw, but let's do our best. Our base is a cube, so I'm going to kind of draw a cube here. And what I'm doing is I'm putting a hemisphere on top of it. So I'm going to have a circle, half of that going up. If you can kind of visualize that being a hemisphere sitting on top of that. We're asked to find the surface area and the volume. Our cube has side lengths of 4, and that means this distance across is also 4, so the radius for my circle is going to be 2, or I'm sorry, for my sphere. So let's talk about the surface area. I've got a little bit of a mess going on here. To find my surface area, what I need to do is find 5 sides of the cube, because the top is not complete. I will need to add the hemisphere, and then I need to deal with these little pieces in the corner. All I have on the top is 1 square minus the circle, because that part doesn't show because the hemisphere is sitting on top of it. All right, so let's think about the cube. Each side is 4 by 4, making that 16. So what I have is 5 sides of 16. The hemisphere is going to be half the area of the surface area of the sphere. So this is half of 4 pi r squared. So this is half of 4 pi times 2 squared. So this is going to be 8 pi. 4 times 4 is 16, half of that is 8. And this is 80, which we'll just carry down for right now. And then we have this part here. So I need to do one of the squares, which is 16, minus the area of a circle. So minus pi times my radius squared. So I'm adding 16 minus 4 pi. Now all we need to do is combine these and see what we have. I can put those parts together, so we have 96, and I'm going to take care of that subtracting. And so I've got 96 minus 4, I'm sorry, plus 4 pi. And this would be in square inches. The volume's a little bit easier because we don't have to worry about the inner sides that we can't see. In this case, my volume is just going to be the volume of the cube plus the volume of the hemisphere. I want you to stop the video and do this one on your own, and then turn the video on to check it. I believe you got 64 plus 16/3 pi cubic inches. Again, volume is going to be cubic inches. Alright, so let's look at this next one. I want you to stop the video and try to sketch this on your own. Then start the video again and see how well you did. Make sure that you label everything. Hopefully you have something that looks roughly like this. I did my square prism, the base of it kind of at an angle so you can see the part that's cut out. So when we do the surface area, let's think through what we have. We have all of the sides of the cylinder. So we're going to have all of our cylinder. But we're not going to have, we have to take out, since we're taking out that rectangular prism, that actually ends up adding surfaces inside the cylinder. So we're going to need to add the 4 rectangular sides inside the prism, or inside the cylinder. So surface area for a cylinder would be 2 pi RH plus 2 pi r squared. The only problem is we have two holes, top and bottom, that are not going to be considered as part of the cylinder. So we would need to take out the two squares. So we're going to have 2 pi, my radius is 3, my height is 10, minus 2 squares that are 1 by 1. That gets the cylinder part. For the rectangular sides, each one of those sides has a width of 1 foot and a length of 10 foot. So this is going to be adding 4 times 1 by 10. So let's do some work to simplify this. This would be 60 pi. This would be 9 times 2, so 18 pi. We're going to subtract out 2 for the holes at the top and the bottom. And we're going to add 40 for the surfaces inside. So when we go put all of this together, we're going to have 78 pi plus 38, and this will be in square feet. Now once again, I want you to stop the video and I want you to do the volume. Volume again is a little bit easier. It's just going to be the cylinder minus the prism. So let's go ahead and think through what you would need to do there for volume. You're just going to use your formulas for your cylinder and your prism and then subtract. So stop the video and I want you to calculate that on your own and then start the video again. So hopefully you got 90 pi minus 10 cubic feet. The last part we want to talk about is geometric probability. Basically what happens here is we find the area of the shaded region, the region we're wanting as a success, and we divide that by the area of the whole thing. So if you're looking at this rectangle here, the probability that it falls in the shaded region is going to be the area of the circle, which is our shaded region, over the area of the rectangle. Stop the video, and I want you to go calculate that. So we should be getting 25 pi over 300, which reduces to pi over 12 in fraction form. If you divide that out, you'll get the decimal point to approximately 0.262 or 26.2%. So let's look at the target problem. It tells us that the width of each ring is 4 inches. So this is 4, this is 4, and this is 4, which means for this middle one, our radius would be 2. So to calculate this, we're assuming it lands on the board. So let's find the board to begin with. This would have a radius of 4 plus 4 plus 2, or 10. So my area of the board would be 100 pi. So if I want the bullseye, this is going to be pi times that radius squared over my 100 pi. So I get 4 pi over 100 pi, which is 1 over 25. The middle ring's a little bit trickier because I have to subtract that out. What I'm going to do here is the middle minus the bullseye. So this is going to be pi times the middle, which would be 6, have a radius of 6, minus the bullseye, which we've already calculated. You cannot just subtract your radii because they get squared. This is 36 pi minus 4 pi, or 32 pi. So the probability would be 32 pi over 100 pi, which reduces down to 8 over 25, which is 0.32 or 32%. Stop the video and do the last one on your own. And this is what you should be getting. Our final look at probability is probably the easiest part. This is just on a number line. What we look at here, 1, 2, 3, 4, 5. So I know that AF has a length of 5 units. So for example, if I wanted to find the probability it falls here, it's going to be 1 out of 5. So for FA, that would be 1, 2, 3, 4, 5 out of 5, which would be 1, which means it's certain to happen. Go ahead and calculate ED and CF. Your teacher will check this when they check your notes in class. At this point, you should go on and do your Tier 1 and knowledge check.